Okay. I'm going to go through this very quickly because there's no real reasons. I'm just going to define these for you guys because it's something that will come up a lot in grade 11. So I do want to make sure you've seen it, and there's no guarantee that you saw it in your regular math class. It's more important in physics and chemistry than it necessarily is in math, but I do want you to see what this is about. So, like I say, I'm just going to explain what they are. So, natural numbers. This is the first set of numbers that we have. All the numbers in our universe are real numbers. There are imaginary numbers, but you don't have to worry about them until university. So, if you're having trouble with the real numbers, which is the math you've been doing for the last 11 years, then just wait until you get into imaginary numbers. But for us, we use the real number system, and it's broken down into groups. The first group is the natural numbers, which I like to call the counting numbers. If we all started to count together like we were in grade 3, we would all go 1, 2, 3, even though the first number is what? 0. But we would all start counting at 2. So the natural numbers are the counting numbers. 1, 2, 3, and how far can we go? Infinity. Okay? Everybody cool? All right. The whole numbers. They're all the natural numbers plus 0. So the whole numbers are 0, 1, 2, 3, ... up to what? Infinity. Yay. Then we get the integers. The integers are all the whole numbers plus the negatives. So the lowest number is negative infinity, negative 2, negative 1, 0, then 1, 2, up to positive infinity. Is everybody cool with that? Now, why that is important comes in, like I say, it's more important when we're doing measuring of things. Okay? For example, often when you are measuring something and putting it on a graph, you can't have a fraction. You understand what I'm saying? So you would have to use natural numbers, whole numbers, or integers. Sometimes when you're measuring something, you can't have negatives. For example, can you have negative time? Can time go backwards? No, unless you have a 1985 DeLorean with a flux capacitor that can generate 1.2 gigawatts and go 88 miles an hour. Thank you. Okay, we'll carry on now. Also one of the greatest movies ever made. Again, some of you will say, I've never seen it, which will make me cry just a little bit inside. I know, and I'm already crying inside. I don't know why you want to hurt me so much.
Because I donated my money to charity.
Lies.
How do you go back? Yeah, how do you go back to it? You go to the top and go back.
See the movie. It's on Netflix.
That's $7.
Back to the Future.
I'd rather give people $7.
But you won't.
How do you know?
I'll put money on that.
Maybe you won't.
All right. Now, guys, before we go any further, I want you to notice, what do you notice about those 3? What's missing? Simran? Right. No decimals. And if there's no decimals, there's automatically no what? No fractions. Because fractions are decimals. All you guys like, oh, I hate fractions. I only like decimals. Makes me angry because they're the same thing. Now, rational numbers are everything from up there plus fractions. And as soon as I add fractions, what does that automatically bring to the party? Decimals. Okay? Everything else, as long as it's a fraction, goes into rational numbers. Now, I haven't written down the word decimals for a reason, because it's only fractions that are rational numbers. And here is what I mean by that. A rational number must look like this. I'll just wait so I can save the world. Must. Please underline, highlight, draw blue Mrs. Bag Crumble cloud around it. I don't care what you do. Must be x over y. It must look like that. And x and y must be integers. And y can't be 0. If you have any fraction, which is a number over a number, and those numbers are integers, you have a rational number. Okay? And then irrational numbers are what's left over. And those leftovers are decimals that never repeat or end. So, for example, pi, because pi doesn't end, right? Pi is circumference over diameter, correct? So that looks like a rational number, doesn't it? But it's not, because the c, either the c or the d, is not an integer. Okay? Pi is irrational. So are every root that is not perfect. So the square root of 2, irrational, because it's not a perfect square. Square root of 3, irrational, because it's not a perfect square. Square root of 4? Square root of 4 is irrational? It's rational, because square root of 4 is 2. Square root of 5? Irrational. Everybody cool? Okay. And that's really all I want to talk about there. But I would like for you to turn over the page, because there's 2 things I want to do on that. I'm not going to spend a whole bunch of time on it. What's that as a fraction? 12 over 100. Would you leave it that way if you were in grade 4? No, you wouldn't. What would you do? Simplify. No. Reduce means make smaller, but you're not making it smaller because it's the same, isn't it? Right? That's 3 over 25. Right? That's all I want to talk about there. What about this one? It's 1 over 9. Anytime you see a repeating decimal, a repeater, it's over 9. What about this one? 2 over 9. Excellent. What about that one? You want to say 54 over 99, but that's not right.
54 over 9.
Nope.
54.5 over 999. 5 over 9. 5.4 over 90. 5 and 4 over 9. 5 over 9.
It's 49 over 90. I know it makes no sense. Yeah, it's 49 over 90. And if you don't believe me, you check. 49 divided by 90. 0.54444444. Well, you just kind of follow it. There's a way to get to it logically. I'm going to just cheat because it's summer. I'm going to show you what it is. If only one number repeats instead of both, I already told you if every repeater gets a 9, right? So I got two numbers there, which should be over 100, yes? Right? Because it's hundredths, 0.54, just like this was 12 over 100. But I got one repeater. So I got to have a 9 to cover that repeater. But this 5 doesn't repeat, right? So I leave it as 0 because it's nothing to worry about. Okay? Now, since I've already counted that 5, if this little line wasn't there, that would be 54 over 100, correct? Yeah. But I'm not counting that 5, right? So what math gets rid of that 5? I would subtract. So I got 54 minus 5, which is 49 over 90. Because you only need one repeater. Yeah. So what if I add 0.67 and the 7 repeated? What would that be? It would be 67 minus 6, which would be 61 over 90. Okay? Normally I would take a whole, like half a class to explain that to you. But the neat little trick is this works. So I'm showing you the trick. Summer school, sometimes you learn a trick. Everybody good? 1 sec. I'm going to be done and class is over in like 8 minutes. Nah. That's slow. That's slow and they always let you go early. It's 12:55. Yeah, but they always let you go early. Mr. Brach comes on the announcements at around 1:05, says, no hats, don't park where you're not supposed to park. Make sure you're here every day on time. And if you miss 2 days, they will kick you out. And then he says, with your teacher's permission, you're dismissed. And it's always before 1:10. Then go. Huh? No, because I'm not done. All right. The only thing I want to show you here is two things. This right here, is that rational or irrational? No. Why? It's rational. Why, Fawaz? Because it ends at 4. That's rational. Because that is 319,754,000 1/millionths. Okay? Because it ends. Now look at this one. So this guy was rational.
Irrational.
What about this guy?
3 dots.
3 dots means it carries on, but it repeats. So can we, what's our guess? I'll get to that. That's the point of this question. It looks rational. Why? Because it repeats. Can I guarantee that it's rational? No. Can the 30 billionth decimal place might be a 7? Right? So this appears rational, but it might be irrational. Everybody cool? Okay. What about that one? Is there a square root of -4? No. Is there a square root of -4? 2 times 2 is positive 4. Negative 2. Negative 2 times negative 2 is positive 4. Is there a square root of a negative number? No. That is imaginary. That is why we have imaginary numbers. So we can do square roots of negatives, because they don't really exist. And I think that's all I want to talk about on page 86. Oh, this. No, I'm done with that. You don't have to do 87. Screw it. You have a test tomorrow.
Go study it.
On trig, right? Oh, you got your trig? You got it all wired, buddy? You want to put some gummy bears on that? Yeah, I didn't think so. Okay, everybody cool? Now, one sec. I just want to make sure everyone's good with this. Yeah, I'm happy with that. Okay, so listen up. Tomorrow, and this is recording in case you forget. Tomorrow. First block, notes. Second block, trig test. Third block. I know, right? You think you would have figured it out the first two. Third block, exponent quiz. But don't worry, we'll review. Fourth block, I will have finished marking your tests, your trig tests. I'll return trig test, and we'll go over it. Okay? That's the hope for tomorrow. Everybody cool? Okay, don't pack up. I can see that. Don't pack up unless you want to stand around for 10 minutes. Okay? Listen to me. I explain what's on the trig test. You know what it's going to be on. You know you can bring in your sheet. Right? So you don't even need to memorize SOHCAHTOA. But remember, you're not going to always have the triangles drawn for you. So make sure you go back onto page 70. If you didn't do them, page 70 and 71, make sure you can do those, especially the ones without drawings. Make sure you practice page 70 to 71 for your test. No, because the answers are on the page. So of course you're going to get 100% because you have the right answers. But make sure you can actually do it. Okay? Okay. There's tons of video. I've recorded all of the going over of stuff on page 70 and 71 and all of the going over of the review on page 73 to 76 and the little cheat sheet on page 72 where I said all the tricks I might try to pull on you. Okay? All right.